So welcome everyone. I appreciate the opportunity to speak. It is a sunny Saturday morning here in the Pacific Northwest. I understand that it's coming up on dinner time in Europe, but so I appreciate everyone joining from wherever you are in the world. This is a privilege for me. I really appreciate the invitation and the selection. My name is Paul Turley. I am a Microsoft MVP in the data platform space. I've been working with Microsoft data and business intelligence tools for decades. I've gotten to the point where I've stopped trying to figure out how many years I've been in the industry, but let's just say I'm in my third decade of doing data, business intelligence, and software work. I work for a company called 3Cloud Solutions. I am a director in our delivery engineering practice, which means that I spend a lot of my time training people internally. I do a lot of workshops and roadmaps for our clients who are just dipping their toe in the fabric pool and getting started with new tech. As an MVP, I spend a lot of time with the Microsoft product teams who actually develop these tools. And in my day job, I work both with clients and support a lot of our internal folks. 3Cloud was just awarded for the second year in a row Microsoft Partner of the Year in the data and AI space. In one other category as well. I think it was artificial intelligence. And so we're a consultancy based in the US. We have our headquarters just south of Chicago, but we're a kind of a virtual remote first company. We have about 700 employees, 700 something. And our data and AI practice, where I work in, is nearly half of the company, about 400 people. And I used to help manage and direct our business intelligence practice as a people manager and supported a number of clients. And now I'm in this role where I'm doing a lot of internal training and support. So I'm going to talk today about moving from Power BI to Microsoft Fabric. I'll give you just a little background on this topic and the title that I've selected. I do speak at a number of conferences, user groups, and events. I help run our local user group here in the Portland, Oregon, and Vancouver, Washington area. And but participate in a number of different user groups and do a lot of presentations, mainly around business intelligence. And I did speak at the first FabCon conference in Las Vegas earlier this year on using Power BI with a lot of data, and talked a little bit about Fabric, but it was mainly around Power BI architecture and Power BI best practices, doing Power BI the right way. On my blog, which I will share with you right here. On my blog, as I was preparing for my presentation at FabCon back in March, I was just kind of thinking out loud around what it would take and what people should be thinking about as they're thinking about kind of moving Power BI into the Fabric platform. So I posted this blog post, and I'm just sharing some thoughts. I mean, when I have things in my head that I want to get out, oftentimes I'll blog about them, and sometimes that blog post is going to be a little scattered and a little fragmented, and then I fill it in as I go. And so if you follow my blog, you'll see that sometimes I'll post and then I'll update that post a few times. And anyway, so I posted this article, Moving from Power BI to Fabric. And I don't have the most popular blog in the world, but I've been blogging since 2009. And so it's been a going concern. I do have a number of followers, about 5,000 or so, 6,600 subscribers now. And I've had a little over 2 million unique individuals looking at my blog. So, it's been out there, and it's something that a lot of people follow. But I got more hits on this article than any other article ever. And if I went and looked at the statistics, I think that about 60,000 different people have read this article. And that's not to say, hey, look at me, I have a really popular blog. It's to say this is a popular topic. This seems to have struck a chord with a number of people. And so I've pitched this as a new conference presentation topic. But I've not yet fleshed out a deck. I don't have a lot of really polished and well-practiced content, but I do have a lot of content. I have a lot of talking points, and I do have some demos for you. So with that said, I am going to encourage you all to be as interactive as possible. Please ask questions. Raise your hand if you like. I'll try to keep an eye on the chat window. And I also do need to be mindful. I'm used to doing presentations that are 60, 75, 90 minutes in length. We only have 45 minutes here, so we'll be mindful of that. But just don't be afraid to speak up and ask questions. There are no dumb questions. And we'll all be helping each other out. So I am going to go to a deck that I'm beginning to kind of flesh out. But again, I just wanted to kind of set the expectation that this is not a real slick, polished presentation simply because it's a new topic. And that's a work in progress, and that's a work in progress. But let's start with this slide. Let me just ask some questions really quickly. I don't have a poll set up, but I just will ask you all to just chat some responses very quickly in the meeting, if you wouldn't mind. How many of you work with Power BI in an enterprise capacity, meaning that you use Power BI with enterprise data sets, you work with substantial volumes of data, and or you build BI and reporting solutions that are of enterprise class and enterprise scale, where you're serving a lot of users with a lot of data? Just give me a really, really quick chat. Just say, yes, enterprise, or no, I more of a self-service user. Just want to get a taste for where the audience is coming from and what your interests and experience are. Okay. Appreciate that. Keep the responses coming. Yes, Donald. Donald and I are familiar. I know of your background. All right, well, so let's talk a little bit about the business intelligence process. And I've used this in some earlier presentations, so if you've attended other presentations, you're going to see some recycled material, but I'm getting to a different point. There is a well-established process for the way that we manage data in the business intelligence realm, and that is that it's very much an iterative process. But if we kind of break that down and kind of flatten it out into a waterfall. So if we look at one iteration of the BI process, it's important to start with a plan. It's important to understand our requirements as much as possible. The challenge with that is that often when working with people who primarily develop software or database, maybe transactional database systems, it's very common in those disciplines to get all of the requirements up front, to make sure that we understand every single thing that the user needs, and just understand exactly what tables and columns and metrics and all of those things that we need before we get started. And that is a very difficult thing to do in the BI process, simply because a lot of users and business stakeholders just don't understand the art of the possible yet. They really don't understand what it is that they can have. And so if we can at least get direction, or maybe our highest priority requirements, we can go through an iteration of design and delivery, show them something, say, oh, okay, well, that's great. I see profit now. Can you show me EBITDA? Can you show me net profit? Can you show me predictions? And so it becomes this very iterative process. But it looks like this. We start with a plan. We connect to our data source. We then transform, shape, and cleanse that data. At the center of a Power BI project or any Microsoft business intelligence initiative is the dimensional or semantic model. And it's critical to understand that Microsoft BI tools, the Power BI platform, is really centered on that semantic model, which ideally should be a star schema, or at least a snowflake-like schema with fact tables, dimension tables, and there could be some exceptions. Generally speaking, we need to build that really solid semantic model. Then we build calculations, metrics, measures on top of that. Then we can visualize. Once we've proven the concept, we have report pages with visuals, then we publish, we deploy that out, and then we manage that, secure it, etc. And I'm not going to walk through this. This is a metaphor that I've used many times in the past, essentially saying that building a BI solution is a lot like building a house. And the point is that there's a very well-established process to building a house. You have to start with a blueprint, and you can't just make it up as you go along. But you build a foundation. That's your model. You frame it, you put walls on it, you put in your windows, and you landscape it. And you can add on to a house, but it's better to have a plan and to understand your requirements ahead of time. All right, so let's back up and think about how this relates to conventional Power BI architecture. I'm going to pause and read this question real quick. I know what kind of problem we might face when we move from Power BI to Fabric and how to address those. Absolutely, we will definitely talk about that. So when we use Power BI only to perform all of these steps, our get data, transformation, and model is all performed in Power BI desktop. And you might use some external tools like Tabular Editor and DAX Studio to set more advanced properties. Maybe you're managing partitions and incremental refresh. But for the most part, you're going to do all of your work in desktop. And the data connections, transformations, all of the cleanup and the shaping is going to be performed within that Power BI project using Power Query primarily as your data shaping tool, and then building the semantic model within Power BI desktop. And it's all managed within that PBIX file or a Power BI project and then deployed out to the service. So as we think about Fabric, we now have the opportunity to take those upstream processes. So quoting Matthew Roach, who was kind of famously quoted as saying that we want to move data transformations upstream as far as possible and downstream as far as necessary. So that upstream as far as possible, if we're building an enterprise class solution, and if we want to be able to share things like data connectivity, transformation, cleansing, perhaps even modeling, if we can move that outside of our Power BI project so that these are shared assets, and if we're moving data at scale and working with very large data sets of data, then it might make sense to perform that data engineering and transformation work outside of the Power BI layer. And this is where Fabric essentially gives us that opportunity. I'm going to pause just a little bit and let's talk about what Fabric is. I will ask this question while I'm talking. How many of you are working with Fabric in any capacity today? Whether you've just played with it or you're productionalizing it, maybe getting started with some proof of concept projects. But if you are working with Fabric at all in any way, then please respond. All right, so you're using an F2 capacity, great. And I'm F16 for customer projects. Okay, and a Power BI license. Awesome. So when I first saw Fabric, and it was called Project Trident at the time, it was at the MVP Summit 2 years ago, March. So nearly 2.5 years ago. The way that Fabric was introduced to us at that time, and this was highly NDA, it was early private. It hadn't even been made available to any partners or MVPs yet. But as Amir Netz and Arun Ulag we're kind of pitching this new platform, this new concept, the perception that I had was that this was Power BI plus. So they started with the Power BI service and layered into the Power BI service the Spark engine, data transformation components, which included the kind of a leveraged version of Azure Data Factory. On top of the Spark engine, they added Jupyter Notebooks. They then added what became known as OneLake, a storage layer that was universal across the entire tenant, where data was stored natively using Parquet file format with a Delta layer on top of that, all managed with the Spark engine. and this was really revolutionary for Microsoft to be able to say, we're embracing open source, we're embracing industry standards that Microsoft didn't invent, and we believe that the future is utilizing the Spark engine, which of course is not a Microsoft technology. And we're betting the farm on this, but it's going to be part of Power BI, and you will now be able to take this get data, transform, and modeling experience and perform that outside of Power BI desktop, but it'll all be managed in the service. So we saw this as really part of the Power BI ecosystem. So let's back up and talk about what makes Power BI so magical. Why is it so fast and so efficient? Why can we do lightning fast reporting and interactive analytics with Power BI using a lot of data? And a lot of this comes back to the VertiPaq in-memory engine. So we're not talking about Fabric right now. We're just talking about Power BI. And going back before Power BI, SQL Server Analysis Services, tabular mode, utilizes an engine called the VertiPaq engine. This is an internal name. And it's an in-memory cache. It just means that we take all of the data, we put it up into memory, and all of the data, column by column, is compressed. And it uses a compression algorithm, much like zip, but might use different encoding mechanisms to compress the values in every single column of every table. And so if we can be particular about the columns that we include in tables. So if you've got a table with 150 columns, you probably don't want to include 150 columns, but maybe there are only 8 columns that you really need. So you bring in those 8 columns and make sure that they have the right data type, and we shape and transform that data so that we're being very conservative. And that data is going to compress, and it's all going to fit up into memory. And then we can interact with that in-memory cache. Utilizing the storage engine and the formula engine. I'm not going to go into that in detail. So with the introduction of Fabric, essentially what they did is they said, well, instead of using our own proprietary storage mechanism, we're going to natively utilize Parquet Delta format, but we're going to put VertiPaq on top of that, our in-memory engine. Since Parquet already does the whole compression thing, that's going to be a native experience. And so Parquet Delta plus VertiPaq opens the doors to working with larger sets of data, making Power BI part of a larger ecosystem, and being able to embrace Apache Spark and notebooks and enterprise scale technologies and tools that can make this a much richer experience for the right people. Now, I want to point something out. This is a diagram that is part of some common Microsoft marketing materials. You'll find this on the Microsoft Learn site. But this makes the point that we have this whole data engineering experience now within Fabric, where we can use Data Factory and data warehouses and data lakes, and all of this sits on top of this OneLake layer with data stored natively inside Parquet files with Delta sitting on top. All of that is wonderful. In the past, with Power BI, we've had import mode, which we know is fast, but it has some size limitations. And we've had direct query, which gives us access to real-time data, but typically at a performance cost. But now we have Direct Lake, which which in essence gives us the best of both worlds. Direct query can be slow, but it's real time. Import is fast, but there's some drawbacks in terms of size and scale. But then they label Direct Lake as being perfect. And I personally take exception to that. So I get the point. I think it makes a good point, but I think that a lot of people come away from Fabric presentations and demos thinking, oh, we have to do Direct Lake. That we're going to have to throw away everything that we've done, and we've got to put all of our eggs in this basket. And I want to kind of put a pin in that question. All right. I am going to just jump into demo land here real quick. Actually, I'll go back to my blog post, and I'm going to pause and catch up on questions now. All right, trial on personal tenant. Yes, Christian, I'm in the same camp as you are. Aside from the resources I have available through our partner network. And Donald, just for Power BI and paginated so far. Yep. Lots of Databricks, and there are a lot of parallels with Azure Databricks. And then Power Pivot in Excel, also using Vertipack. Yes, so the Vertipack query engine is also baked into Power Pivot for Excel. So this is a universal technology that Microsoft has implemented in a few different places. So in this blog post, and let me just paste this into the chat so that you all can enjoy it. This is essentially what we've talked about so far, and a perception that I'm finding with a lot of our customers who are being introduced to Fabric is that they see Fabric as being disruptive. And they think, oh my gosh, there's so many things to learn. I have to learn how to use notebooks and pipelines and choose between a lakehouse or a warehouse. And then if I've got real-time data, then KQL databases and streaming intelligence. And it's just so much. It's just so much. Fabric is so big and so comprehensive. And does that mean, excuse me, does that mean that we have to start from scratch? Excuse me. Does that mean that we have to start all over again? And I want to make the point that you don't need to make any changes, that Power BI still exists within the Fabric platform, supporting import mode, direct query mode. You can create composite models. You can use hybrid tables, all of the richness, aggregations, all of those advanced level features that we've had for a few years now. All of that is viable. And none of that goes away. Direct Lake doesn't necessarily replace the need or the value for all of those things. But in certain scenarios, Direct Lake is a very, very compelling story and a very compelling capability. James, looks like you've got a question. And you're welcome to come off mute if you'd like to open up your microphone and just ask your question. All right. Oh, sorry, I must have accidentally clicked the hand button. All right. Let's see. Is it that Direct Lake approach will take more compute costs than import mode? Not necessarily, but that's a really big it depends. But let's get into that. So if we now look at the data shaping and storage aspect of Fabric as existing outside of Power BI, and then think about Power BI as everything from modeling forward, and modeling is kind of a fence sitter here, quite honestly. All of this work will be done utilizing Fabric workloads, such as Dataflow's Gen 2. So as Power BI people, as we think about using Power Query to perform our data transformations, you may choose to use the new Gen 2 Dataflows, which literally is Power Query in the Fabric environment. If you are a Spark advocate and you're working with very large sets of data, then it might make sense to use notebooks, which in certain cases can actually be faster and more efficient because they utilize the Spark engine, Spark pools and clusters and all of those technologies. That can use a lot of compute, but I think if we were to compare a Power BI model of the same size, let's say that a Power BI solution would result in importing, I don't know, 5 GB of data with moderate transformation. That's not a whole lot of compute. It may be some long-running queries, but most of those queries are, ideally going to run against the data source. Transitioning that to Fabric does move it to perhaps a different engine, maybe to the Spark engine that can be more efficient. I don't know that there's necessarily more compute here, but it just gives us the ability to offload all of that using some other components that might be more efficient and easier to manage going forward. So I think that whether or not it uses more compute is really a big it depends question. All right, let's jump over into the demo. I don't need to switch windows. I need to switch tabs. All right. So in a typical Power BI solution, we're going to perform all of this work in Power Query, and I am going to open up Power BI Desktop as I continue talking here. And I want to show you the new Power Query experience in Power BI Desktop. While I'm waiting for that to open, I will open up this data flow. Okay, Power BI Desktop is opening on another monitor, which I will switch as soon as it goes full screen. All right, still waiting for this to open. I'll read your question. How do we decide whether to go direct link or import if the data set size is within 7 to 8 GB? Boy, there's just a lot of it depends here. Prior to Fabric, we've had the ability to manage data sets or semantic models up into the tens and 100 of gigabyte sizes. I've worked with clients with Power BI data models up to 400 to 600 gigabytes in size. However, that's an extremely expensive proposition. A particular client had to upgrade from P1 up to, I believe it was a P5, in order to manage a 400 gigabyte data model. Very, very expensive. It's like $80,000 a month in order to do that. Possible, however, not entirely practical. Moving a data model of that size into Fabric, a lakehouse can easily handle data of that size in an F64 capacity, which is roughly equivalent to a P1. So, going back to your question, 7 to 8 gigabytes, well, that all is manageable in import mode using a P1 or an F64. Even less. I don't have all of the size limits memorized, but you could probably go down to an F16 or F32 easily. But there are some advantages, and I'm going to talk about some of those advantages right now, not necessarily with regard to size. All right, let's jump over here to Power BI Desktop and open up Power Query. Now, what I should have shown you, because the new Power Query experience, it creates a modal dialog that I can't switch to. In fact, I'm going to close it. I'm going to go to my options, and in the preview features dialog, I'm trying to find my mouse. There it is. Here is the new Power Query experience, currently in public preview. It's been out for several months now, so it's a pretty solid interface, but still in public preview. I can turn that on, close Power BI Desktop, reopen it, and Power Query now changes quite a bit. So they just moved me from a 16-inch laptop screen to a 14-inch laptop screen, so my screen resolution is a little less than I'm accustomed to. But I just want to show you that there are a number of new panes here that make this a much richer experience. Probably the most obvious change that you'll see here is that my query steps now are in this diagram view. And I can go over to my view menu and you can see that I can enable different views. But here in diagram view, I want to show the steps, and rather than the query settings that I still have over here, which are enhanced with some new icons, each of my queries now can be diagrammed in this way. So I see the steps flowing from left to right. I also see my query dependencies and my parameter dependencies depicted in this diagram view. This is cool. This is rich. It is a much better experience on a large monitor. I just want to share my high resolution 4K monitor with you here in Teams. But we also have the M code window right here, and this is script view. So I have my query script view turned on. This is completely interactive. So I no longer have to right click, go to advanced editor and view the code. So we just have that code right here. As we make changes, you'll see your code changed. If you want to make explicit code changes, then you'll see that reflected here in the diagram view. And of course, we still have the data preview just like we have before. All right, so this is the new Power Query experience in Power BI Desktop. Well, close that, minimize that. This is a Fabric Data Flow Gen 2. And as you can see, it is exactly the same experience here in the browser. Again, I'm a little starved for screen real estate, so things are a bit compact, but it is exactly the same functionality. And so you can design your queries within Fabric. This is outside of Power BI, where you use get data, you choose from the same data sources. But what's different here is that the output of every query has a destination, and you can choose from these destinations. This can be a Fabric Lakehouse, I'm going to go here. All right, so this could be a lakehouse. That didn't do what I wanted it to do. I'm going to close this and just not save my work. All right, so these are my destinations. This can be an Azure SQL database, it could be a lakehouse, it could be a KQL database, or it could be a Fabric warehouse. So you can now output to any of these objects. I would say that as a starting point, if you're getting started with Fabric, I would output to a lakehouse. If you prefer to do everything in SQL and to manage your Fabric data storage asset using T-SQL, you could optionally use a warehouse. But let's just restrict our conversation to a lakehouse. What is a lakehouse? A lakehouse is a data storage item that stores data in Delta Parquet format using strong schemas, which means that we have well-defined tables with defined data types. We can have schema-bound inferred relationships. We won't get into what that means exactly. And there is a SQL Analytics endpoint that you can use to run T-SQL queries over the top of that lakehouse. So it looks and feels like SQL Server for read-only queries only. If you want to be able to create tables and insert and update records using SQL, then you'd use a warehouse for that. So because that data in the lakehouse is natively stored in Delta Parquet format, then that enables the ability to use the direct lake storage mode. So how does that work? Let's go back to my workspace. Let's close this first. Yes, I want to exit. Just occurred to me that I saved that change that I made, so I'm going to have to go back and fix that after this presentation. So back in my workspace now, I can create a new semantic model. So this is a model that's created based on that lakehouse that I design here in the web interface. When I open up that data model, you're going to see a modeling experience that is very similar to Power BI Desktop. Okay, let that open up. I've always been an advocate of using desktop primarily to do design, but I'm a big fan of using these web tools now. So as you can see, we can design our data model just like we would in Power BI Desktop. We can drag and drop these tables around. We can create different layouts. Here is a diagram layout just for my online sales fact table. Typically, when I have a data warehouse type data model with multiple fact tables, I'll create a layout surrounding each of my fact tables like I've done here. I can design my relationships. I can create my measures. All of this is possible. I can also connect to this semantic model using the analysis services XMLA endpoint and use Tabular Editor to do my modeling work. So I could enhance my model using Tabular Editor. I could write queries using DAX Studio. And as a preview feature right now, you can actually connect Power BI Desktop up to a published direct lake semantic model and use Power BI Desktop as a design tool against a published model. So this kind of becomes the preferred way to do all of your modeling. All right, so what are the trade-offs? Why would I want to use this method? Why would I not want to use direct lake? I'm going to jump over to my PowerPoint presentation if I can find it. Oh, hold on. What did I do? Apparently, I have a video embedded in my PowerPoint presentation. All right, so our users are saying they want it all. We're managing our data in our lakehouse, and we have pipelines and data flows that are running very frequently to update that data. And our users are saying, we would like to see those real-time updates. We would like to see the data as it exists in that lakehouse in Power BI without having to do a model refresh, which we would have to do in import mode. So we need access to large volume of data that may have been a challenge with import mode in the past. We need near real-time reporting against that lakehouse. Our developers want to use tools like notebooks and pipelines and other enterprise data engineering tools, and we want to make sure that we have room to grow. So direct lake mode may be the right solution for you. So couple things to bear in mind. There are limitations, but the limitations are much, much greater than they were with import mode. Some of the limitations which we refer to as guardrails are that if you have an F64 capacity, this is equivalent to a Power BI P1, that a given query can only access up to 5,000 Parquet files. And what that means is that let's say that those Parquet files are partitioned by week. And, so the 52 weeks in a year, do the math, we're talking about 10, 12 years worth of data. But every time that you insert or update a record, then the Spark engine is going to create new Parquet files, and so that can increase the number of Parquet files. So we're really talking about large volumes of data, but there is a limitation. If we were go down into this realm, we're talking about 1,000 Parquet files per table. Still a lot, but it is a limitation. So what happens when you have a lot of Parquet files in storage and you haven't cleaned that up to reduce the number of Parquet files, and then a user goes and browses data over 10 years and it hits more than 1,000 Parquet files? What happens is it falls back to direct query mode, and that user's experience is going to slow down a lot. In terms of data volume, again, look at F64. 1,500 million, so we're talking about 1.5 billion rows per table. So if you've got a fact table with more than 1.5 billion rows, and a user is running a query that actually consumes that number of records, it will fall back to direct query. Again, it's a lot. 300 million in a SKU smaller than F64. So there are limitations, but those limitations are far higher than what we've had in the past. So let's do a quick comparison. So as you're transitioning to Direct Lake, before you were doing all of your modeling in the Power BI desktop. Now you're doing data integration using Fabric assets that populate a lakehouse or a warehouse. You may use Dataflow Gen 2 instead of Power Query in Power BI Desktop. You cannot use calculated columns. This is a limitation because your tables have to be defined using Parquet files. And so the only way to create a calculated column would be to add a new column in your data transformation layer that adds that column to a table in the lakehouse. Just realized I can't see my Teams window here. All right, we're close to running out of time, so I'm going to move ahead a bit. So don't freak out. You don't have to change anything. Import mode is still viable. I still think it's the best choice in a lot of scenarios. And especially if you're creating composite models, if you're combining direct query and import mode in a single model, if you're using aggregations, if you're using hybrid tables, you don't have to change all of that. And those projects are actually going to be a little more difficult to transition because now you need to get all of that data into a single lakehouse. You cannot combine data from multiple lakehouses. I don't know if I have a slide on this, but I'll mention that one of the restrictions is that the source for your queries in a model, let me back up. The source for your tables in a semantic model using direct lake mode must be a lakehouse or warehouse table. It can't be a view. And the reason for that is that it has to touch those Parquet files directly. So you cannot use shortcut tables. So if we have a client whose data warehouse was in AWS Redshift, and they said, well, can't we just shortcut all of our tables into a lakehouse and then do direct lake on top of that? And the answer was, no, you can't do that because it has to be physical Parquet files. And you don't use views, which was common in the past to use views over a data warehouse to enable query folding. So in summary, import mode is still very viable and is a good place to start. In order to apply best practices using import mode, use date range filters, coordinate different report types. You can use paginated reports for transactional reporting and Power BI interactive reports using an import mode model. Use incremental refresh. All of that is still viable. Direct lake mode makes a lot of sense when you've made this transition to Fabric and you are storing your data in dimensional form within a lakehouse. So you want to populate your fact and your dimension tables. And then import mode with direct query using composite models, hybrid tables, those kinds of things, still very viable. And then dual mode aggregation, some of those advanced features don't really have equivalents for direct lake mode, and probably because it's really not necessary. Direct lake mode is fast out of the box. You just have to do a lot of the heavy lifting during data transformation. So that is what I have prepared to share with you today. I'm still be around if you have questions.